Welcome to the Explainer. Today, we're diving into one of the most powerful ideas in cloud computing, going serverless. And we're going to use Azure Functions to see how it all works.
Okay, let's just start with this question because it's a big one. Imagine you could just focus on writing the code that actually matters, the bit that makes your business special, and you could let the cloud handle literally everything else. Well, that's the core promise of serverless. So what do we really mean when we throw around the word serverless? It's actually kind of a funny name because, and let's just get this out of the way, of course there are still servers involved. The whole point is that you don't have to deal with them. You're not the one provisioning them, you're not patching them, you're not even thinking about them. The cloud provider just spins up the resources your code needs right when it needs them, and then gets rid of them the second it's done. And the best part? You only pay for the exact milliseconds your code is actually running. I love this quote because it just nails the concept. Azure Functions are exactly that. Tiny, focused pockets of code. Each one is designed to do one very specific thing, and it just sits there, waiting for something to happen. 1 million. So what's up with this giant number? Well, this is where things get really, really interesting. With the standard Azure Functions plan, this is how many times you can run your functions for free, every single month. You don't pay a dime until your 1 million and first execution. That makes this model unbelievably cost-effective, whether you're working on a tiny side project or a massive application. Okay, so this all sounds great, but how does it actually work? How does one of these pockets of code know when it's supposed to wake up and do its job? Let's get into the mechanics. Every single function follows this really simple but incredibly powerful pattern. First, something has to happen. That's the trigger. The trigger kicks off your code. And then, once your code is done, it produces some kind of output. And here's a key detail. A function always has exactly one trigger, but it can pull in extra data from multiple inputs and send its results to multiple outputs. So what can a trigger be? Oh, just about anything you can imagine. An HTTP request can instantly turn your function into a super lightweight API. A timer can wake your function up at 2 a.m. every night to do some database cleanup. You could have a function that automatically resizes an image the moment it's uploaded to storage. Or a new message in a queue could kick off a whole complex workflow. Now, you might be thinking, okay, but connecting my code to all those different services sounds like a ton of boring boilerplate work, handling connection strings, authentication, and you'd be right. But that's where the real magic comes in, with a feature called bindings. Just look at the difference here. It is night and day. On the left, that's all the stuff you'd normally have to write yourself. On the right is the Azure function. See that little blob trigger thing? That's a binding. It tells the function, hey, wake up when a new file appears here, and it handles all the connection and authentication stuff for you. It literally just hands the file's content straight to your code. It's so much cleaner and more efficient. This efficiency isn't just a cool party trick. It enables some seriously powerful stuff in the real world. So let's look at how this plays out, first with a really smart security automation, and then we'll talk about what it's like to actually build and secure these things. Okay, I want you to picture a scenario. It's a really common, simple mistake that can have huge consequences. Yikes. That is a massive security risk. In a typical company, that might go unnoticed for weeks until a security audit. Or, worse, it triggers an alert that wakes up some poor engineer at 3 in the morning who has to scramble to fix it. But in the serverless, event-driven world, the action itself, the mistake, becomes the trigger. The system is basically watching itself and can react instantly to changes in its own environment. So that function wakes up, its one and only job is to look at that new container, see, whoa, public access is on, and it just turns it off. It's a simple, self-healing action. And just like that, the problem is fixed. In seconds, before a human even knows it happened. That is the power of event-driven automation. It's cheaper, it's faster, and man, is it more secure. That kind of automation is incredible, but you might be wondering, okay, is this stuff a nightmare to actually build and test? And you know what? It used to be. Debugging these distributed systems was tough, but today, the tooling has made the whole experience incredibly smooth. You are absolutely not flying blind anymore. Developers can run this entire complex cloud system right on their own laptops. You can set breakpoints in different functions and watch the whole process flow from one to the next. You get these amazing dashboards that show you everything that's happening. It's a total game changer.
Okay, last but certainly not least, this is a crucial piece of the puzzle. Once you're ready to go to production, how do you handle your secrets, your connection strings, your API keys? You definitely can't just paste them into your code. Well, the modern and by far the most secure solution is something called a managed identity. The easiest way to think about it is like giving your function its own secure ID badge inside the Azure cloud. This means your function can just walk up to another service, like a secure vault, show its ID badge, and get the secrets it has permission to access. And think about what's missing there. There are no passwords, no API keys, no connection strings stored anywhere in your code or your configuration files. It is just a fundamentally safer way to operate. So that brings us to the final question, and this one's really for you to think about. From fixing security holes automatically to processing data on a schedule, the possibilities here are just endless. It really makes you wonder, what's that one boring, manual, tedious task in your own workflow that could be completely automated away by a simple, cost-effective little pocket of code?